let's now talk about building up the SDN side of things. So this is layer 3 rooted access, and I've got non-SDN, but what I actually meant to say there is the underlay. So let me fix that quickly. Yeah, so let's move on to the layer 3 rooted access. So what we were looking at before was layer 3 rooted access, but with no SDN. So traditional layer 3 rooted access. This is layer 3 to the access layer, but getting ready to prepare for example, software defined access. So I'll mark out a couple of components here, or key components that make up the software defined LAN solution. I've tried to highlight it at this stage in blue. So here I've got, you know, a Lisp control plane router, and we'll talk about how that operates and integrates into the wider solution as we go along. We have some core switches. So these may be, for example, the software defined access border nodes. And then above that, I've got a firewall, but this could be, for example, a pair of VSS or stack-wise virtual switches which are outside the fabric. So this firewall, it could be a firewall or it could be another switch infrastructure. The reason that I've done it like this is just because I want to focus on like the software defined LAN side of things. So then if we move down the stack, then you notice that all these black dots that have connections between them signify routed links. So there's no layer 2 stretch in here. And again, this is the underlay network of the SD-LAN. So there's routed links, and then we have what we call a distribution or intermediate node. And we'll talk about that in a second. And then we have the same access layer nodes down here, which again are all routed to layer 3. And then if you look at the bottom of the diagram, take the pen off and zoom in. The bottom of the diagram, the actual user subnets are on the access layer, right? But there's a difference here. So you might say, Malcolm, but that looks exactly the same as the last one. And it is to an extent, but it operates differently. And we'll explain why when we move into the next diagram. So we still have the application services up the top right hand corner, and I've put a note here. At this point, no overlays or SD-LAN is in place. Users can only connect to their own access layer at layer 2, and layer 3 rooted access. And for layer 3 rooted access, at this stage, we're just preparing the infrastructure. Sorry if there's any typos in the notes. I've put most of it together today. So what I'm saying there is, like, at this stage, you would be able to route from orange to blue, or you'd be able to route from orange to red, but via the distribution switch, just with normal routing. The reason that we've got routed layer 3 routed links and specifically said IS to IS is because that's the recommended protocol to run on the underlay for SD-Access. So let's look at some of the design notes for this then and what's changed. Anything that's in blue, I've added in. So let me go back to my pen and I'll use red this time to highlight things. Oops. Pink color, red, and then go to pen. Right, so basically we've added in or highlighted a few different things here. So we've highlighted the, oops, pen's not working. We've highlighted this here. So SD-LAN management provisioning server. Think of that as DNA center. And then we've also got a policy server, i.e. Cisco ICE. In addition to that, we've got the Lisp. I've jumped ahead. So yeah, so we've got the SD-LAN management server, the policy server, which is ICE. We also have the Lisp control plane, which that could actually be bundled onto what you see as the border node here, or it can be separated out onto a separate router or switch which supports that functionality. And that's all about tracking which end user host is where, which we'll talk about in the overlay section in a minute. The reason that I've highlighted the distribution and marked that as an intermediate node is because at this, for a software-defined access rollout, you might or might not have a distribution node. It might just be core and distribution is collapsed together into a collapsed core where the same box does a similar function, and then the access layer stacks connect into that. So this is really just IP transport in order, because we've got routed links everywhere. I take the pen off. Because we've got like the black routed links everywhere and we don't have any sort of layer 2, these are really just to facilitate for the overlay. So we'll see in the next slide how that works, and these disappear in the next slide, although they're still there in the background, but they disappear from the picture. So what do we have to think about here? Like, let's look at the design considerations and notes. So the main points here are that instead of considering upgrading your access layer from a cost perspective, because before it was like, right, you're asking me to pay this money, what am I getting for it? And it was like, well, we can stop you having broadcast domains, but you're not going to be able to stretch VLANs unless you completely hack the network to make it work like that. And they're like, no, you're okay, I'll just leave it the way it is. When we're looking at software-defined LAN, it's transforming the network. So it's a complete network transformation. We're going from a legacy design to a new design where you get all the benefits of, orchestration and automation. You're able to quickly deploy additional overlay networks, provide segmentation, which is becoming a massive, and not only in the LAN, but also in the wide area network. And it's becoming really easy to provide segmentation in wide area network with SD-WAN, but not so much in the LAN unless you use something like this. It is possible with VRFs and MPLS and all that, but a lot of people either don't have the skills or they don't have the inclination to actually, roll that out with traditional means. So they don't really look at it like, oh, it's going to cost me that, because they know that they're going to need the layer 3 capability in order to provide the SDN functionality in the network. And how this works from like an end user, if I plug my laptop into a switch, instead of like with the layer 3 rooted access having to have like a IP DHCP helper configured on the access layer switch, we would basically configure within DNA Center the edge nodes to forward the requests onto the border node up here, and then that will forward the DHCP request and know where to send it back, so it knows where it's come from and i.e. which access stack where it's come from and where to send it back to. So that's just a little bit about DHCP. We've only got an hour, so I'm trying to cram as much in as possible. The subnet requirements are slightly different. The main subnet requirements are we need routed links between for all the IS to IS links, and equal cost multipath, so load balancing with normal layer 3 routing is used in the underlay network. I think I put in the last slide that a LAN administrator would need to have pretty good routing skills in order to be able to troubleshoot layer 3 rooted access and know what was going on from a manual perspective and a CLI perspective. But there's, it's a bit easier because everything's controlled from the central orchestration engine, DNA center, and for the underlay and the overlay in SDA. The intermediate node, I've said that it may or may not actually be required because it's only transport, but if it does, that could potentially be a Juniper switch. And the main requirement with that is going to be that it supports adequate MTU in order to pass VXLAN traffic, because VXLAN adds overhead to the IP packet in order to create the overlay, just like most overlays, well, all overlays do. We've also got a policy server, which is Cisco ICE, and that's really, you might already have ICE, so that's Identity Services Engine. You might already have that in your network, but I think if I go back to the previous slide, I had it listed, but it was only, if you see here, policy server, i.e. Cisco ICE, but it's only for wireless LAN radius. So you might have to consider that you might need to re-architect your ICE infrastructure or spin up a separate ICE infrastructure or radius infrastructure in order to facilitate software defined LAN. But that's where all of the policy is driven from. And then the final thing was the provisioning server. The idea in this is you've got SD-LAN DNA center servers. It's a cluster. I don't know what it is now, but the last time I looked at it, it was a cluster of 3 servers. And about the reason for that was from a redundancy perspective, and that would support a certain amount of instances of endpoints and things like that. So if you had like a global SD-LAN deployment, you might need to consider, you will need to consider the policy server scaling. So how many concurrent devices can be licensed in the ICE deployment? Because you might have a VM instance of ICE or a lower end hardware instance of ICE on a lower software version that only supports, let's say, 20,000 concurrent devices. And if you go, let's say you've got a 10,000 user environment and IoT coming on, and each user has an average of 3 devices, for example, then that's going to have a knock-on effect to your ICE licensing and the hardware and software capabilities within ICE. So the idea with the SD-LAN management provisioning server, it's the single touch point. That's where you go to configure the LAN where SD-LAN is being used. So I think that kind of covers the underlay. If there's any questions, as I say, there's none come in so far, so hopefully it's clear. But we'll just move on. Just looking at my notes, distribution intermediate node may not be used. The MTU is key, and IS to IS as the the routing protocol. I think you can use like OSPF or whatever, but I think it's the extensions in IS to IS capabilities that are the reason why it's preferred. But there's loads of stuff in the Cisco CBDs about that. So let's have a look at this then. We're moving on to the next stage, and what we're talking about now is having overlays and segmentation. So I'll probably just zoom in on the design notes first of all, because there's a few key points that I want to highlight. So again, cloud, SDN, automation, cloud, SDN, automation, etc. and people, you know, about 2-3 years ago, there was a lot of buzz, or is there not any requirement for networking skills now? Are they going to go away? Are network engineers going to need to be programmers? No, absolutely not. And certainly my experience in anything software defined or cloud orientated, it actually requires more of an understanding. You know, you need people who understand how networking works in order to deliver any of those new services. And the reason for that is because the people or the companies that have created like cloud platforms and automation, not everybody knows how to or will ever get. I'll hold my hands up and say, I've not spent the time really learning Python and Ansible. You know, I'm aware of it and I know how to do basic scripts, but I'm by no means an expert at it. But I can tell by what I've looked at how you actually design all this stuff. It's critical. You're still going to need high-level designs, low-level designs, and you can hopefully it's evident in this presentation that all of the stuff that I've explained, you need to know where you're coming from, and you need to understand how that operates. So when you integrate it into an SD platform, you know how and the pitfalls to look for, and if something gets plugged in, you know, I mean, MTU has gone back since to the start of networking, since any kind of tunnel was created, and that's not any different now with software defined stuff. It might be different numbers and different MTU sizes and things like that, but you know, the principle is the same. And you know, underlays and IS to IS, it might all be configured from a centralized platform via a web interface, but you're still configuring IS to IS, and you're still, if you have BGP or whatever running over Lisp and things like that, yeah, it's taken care of, but you still need to understand it. So that's the first point. I've mentioned the MTU and the intermediate node to done that to death. But the idea with this is at the end of the day, it's simplified administration, so there's less operational burden. So you don't, if you put some crazy design in and it's all in someone's head, then you know it's going to be difficult to support. Even if it's in someone's head and it's documented, it's difficult to support. So the idea with this centralized LAN management / provisioning server, DNA center in Cisco's case, it's to give you, it gives you a good snapshot of what the network actually looks like. If you were to, and this will lead well into what we're about to talk about, but in a traditional network, if somebody was to go to me, Malcolm, I need I've got 5 business units, and they all need to be segmented. And let's just say, for example, how that would normally work. So if I go back to previous slide, what you might actually find for that example, so let's say I add a new color in here and it's another business unit. Well, let me find one that's not being used. Yellow is not being used here. So let's say, right, Malcolm, the yellow business unit, and then there's a yellow LAN there with a user on it. I'm better at doing visuals than drawing pictures, as you can see. But what might actually happen here, and how they provide segmentation, and this happens all the time, how that would have been delivered is a VLAN would be plumbed all the way through to this firewall. That's one option. Or let's say it was here as well. There was a VLAN which is plumbed here, and then you'd have a VRF Lite instance here to here, here to here, here to here, here to here, here, all the way up to plumb into the firewall. And that's if you didn't have MPLS, which hardly anyone runs MPLS in their campus network. So that's for one VRF or one business unit. If you then started saying, well, now I've got another business unit, I'm ahead of my time. I've got an IoT business unit. What's the option? Well, that's a VLAN, but you get my picture. That's either plumbed all the way up to that firewall, or, you know, there's a routed link here, and then a routed link here, and a VRF, and you have to manually configure that all over the place, and you see it gets like really, really complicated. So this is what I'm saying with the SD-WAN, so the SD wide area networks. It's really easy. It's really easy to deploy additional VRFs, or sorry, segments in SD-WAN, whereas a similar kind of thing, if I took an MPLS service from a provider, I would have to get them to configure their core network and all the PE nodes that my devices connect to into different VRFs and present it over and work with the provider. And then, you know, if you've got multicast that runs over that, it all has knock-on effects. So, you know, what we're talking about here with the SD-LAN overlays, this is one of the things that's really kind of good about SD-LAN. I think somebody came off mute there. I don't know if they were going to ask a question or if it was by mistake. I think it was by mistake. No worries. So yeah, so design is still important, and I'm obviously going to say that because I'm a design a champion of design. I think that doing network design and doing, you know, even diagrams like you see on the screen, it makes it so much easier for people to understand. It doesn't have to be the most detailed thing all the time, but I just think a picture tells 1,000 words. And if I was trying to explain all this to you just by talking to you, it would go in one ear and out the other, and it would be the same if anybody was explaining it to me, because it's just, you know, it's somebody just talking. So yeah, so I always find that, you know, design is still a big part. What else is in the design considerations? And then we'll talk about the actual, oh, sorry, I'm drawing stuff. I didn't mean to do that. Rub them out and take the pen off. Zoom in. Hopefully. Oops, there we go. That's better. Sorry about the thing. So, so some of the other things then, we've already covered the first 4 points. The number of overlays, so that's what I just talked about. You know, if you've got VRFs in the WAN and you basically just want to plumb them into the LAN, old school, you have to configure VRFs all over the place, or MPLS, or combination of both. With SD-LAN, you basically have to know what virtual networks. So that's what when people talk about segmentation, that's what they mean. So that's like almost like network segmentation, but there's also something even more granular in SD-LAN, and that's micro-segmentation. And what micro-segmentation is, if you don't know already, let's say in the red subnet pictured at the bottom of the screen, there was me, and I'm just picking the first person off the list. There was Malcolm and there was Alex, and Malcolm was plugged into port 1 and Alex was plugged into port 2. And I wasn't supposed to be able to communicate with Alex over the network. This is where we use our policy server in order, or it might be a group of users. So this is where a policy server and Matrix, if any of you have ever done a DNA Center Software Defined Access lab, or dCloud lab, or DevNet, or anything like that, you'll have seen that there's like a matrix where you say these people can talk to these people and these people cannot talk to these people. So that's how that's achieved. And then also in SDA, the dCloud demonstration is if you're an IoT in an IoT network. So you're in effectively a VRF called IoT, but if I'm lights in somebody else's camera and somebody else's action, and lights can talk to camera, but in action, but I'm getting mixed up here. But you get my point. If action can't talk to lights, then that's where you define your policy. So you can effectively all be in the same subnet on the same switch and not be able to talk to each other if that's what policy you actually want to have in place. So that's micro-segmentation, and then the subnet requirements change again. So if we remember back to the SD, it's not SD, non-SD, the layer 3 rooted access design. So two slides ago, which was effectively the last design because we went through the underlay and now the overlay. But if you look at this design, and I talked about the fact that you need subnetting requirements are increased because orange on the right and orange on the left are two completely separate subnets / VLANs. So on the DHCP server up here, you need two subnets and VLANs, and that creates administrative overhead. When you move into the SD-LAN overlays, orange here, you'll see the different colours here all go into a cloud, and these are like the overlays. So if anybody's familiar with like DMVPN or even SD-WAN, it's the same concept, right? So if I'm in the orange network, I'm in the orange network. What VXLAN brings to the table is it means that if I am, just going to see how to get my pen working again. If orange is 10.1.1.0/24, and then I'm down here and I'm .10, down here I might be .11, right? And effectively this subnet, right? So this is my default gateway here. Let's say my default gateway is .1 for this subnet. So it's .1 here, and it's .1 here, and that's achieved with Anycast. Okay. Now, if that was I'll leave it at that. So that's achieved via Anycast, right? And then what happens is that this is where this device up here comes into play, right? Because it's all part of the same system, right? So what Lisp does at a very high level is it tracks which host IP addresses reside where. And how it does that is it uses a concept called RLOC, which stands for root locator or routing locator, right? So if you see down the bottom here, for the purposes of this example, we've got 1, 2, 3, 4, and Lisp RLOC, right? And effectively, what that is the layer 3 interface of the underlay. So this is the previous slide where we were talking about, the underlay and why we need a layer 3 rooted access. So if what happens here, right, is if .10 wants to talk to .11, right, there's a table which is built up, and what happens is initially it will broadcast up to the rest of the, to this switch here, and it will say, I want to hit .11, where is it? And then what happens, missing out a few steps here, but basically what happens is, because it doesn't know where .11 is on that switch, the Lisp mechanism says, well, I've got a table of that, and it's actually .11 is at RLOC 1. So that all happens at the control plane from a routing perspective. Now, once this host down here at the bottom, .10, knows that .11 is at RLOC 1 over here, a VXLAN tunnel is used, and let me see if I can find a different color. I'll just use this one. Just to illustrate a different color, a VXLAN tunnel is initiated or utilized or used. I can't remember if they're on demand or if they're always up. But that's the traffic flow that basically happens. So to find out where the actual host address is, it will use the control plane. So the control plane and the data plane is separated. And the Lisp control plane router, which could also, just to remind you, could also be co-located on the border node. So these switches here, it could also be co-located on there. But some customers like to split it out. Once it knows where to go, the actual traffic that gets sent just goes direct. So it's similar to like DMVPN phase 3, for example, where you have like a hub DMVPN router, where you have the constant control plane, but then if Site 1 wants to talk to Site 2, it basically builds a tunnel from Site 1's WAN interface in the underlay to Site 2's WAN interface in the underlay, and the traffic is sent over the tunnel. So it's a similar concept here with SD-LAN. It's just it's a lot nicer to operate. So I'm conscious. Hopefully that explains the operation of the SD-LAN overlays. We're at 6:25, so we've got 5 minutes to talk briefly about migrations. But one question, you briefly mentioned using Juniper devices to handle additional MTU. What about using Cisco devices but increasing the MTU size? So yeah, I think that was in regards to with the underlay. My point there was that this box may or may not exist. So this distribution node, it's not critical because all it's used for is routing between the border node and the edge node from an SD-Access perspective. So like it routes over the top. So all I was saying was that it doesn't have to be like a Cisco device because it doesn't participate in SDA. As long as it supports the MTU of 1520 or 40 or whatever VXLAN adds on. So, right, I'll try and explain this as quickly as I can whilst making it clear. Sorry if we go over a couple of minutes. It's definitely being recorded, so if you need to drop or whatever for another meeting, I understand. But to finish off then, what we have over on the left-hand side is we have, I've just put some legacy services, but this is like the core, the distribution, and the access layer. So this is our legacy network over the left-hand side. We've got the firewall, which we talked about if you had to route between different network segments, and then I've just pictured one access on the SDA, but that would just be multiplied by the number of devices, right? So now there's two migration considerations. There's layer 2 and there's layer 3, and then it's linking the two networks together. So if we quickly look at what I've drawn in here, so this all operates as described before. This particular switch stack has only the orange and the blue. Let's say subnet, let's say subnet for the purposes of this, right? So all around what you see here is the software defined LAN fabric. Now we've got a few different connections going from the border node to I've actually got this the wrong way around. I need to draw this in, right? But basically, forget where it's connected, right? But what we basically need to do in order to integrate the two environments is we need to, I'll draw here, we need to connect both the layer 3, so that's what's indicated here. It might be to the core, or you might want to connect it to the distribution. And what that means is like, if you want to route out of the SDA environment, via here, this is how you would get to, you know, any of these services which are up there. If you had, for example, a VLAN 10, let's say that's VLAN 10 here and here. What we need to do, I've got it going up here, but that's actually incorrect. Just let me remember. So forget this line, doesn't exist, but it is an 802.1q trunk. What you would have to do is plumb the edge node into the distribution layer of the legacy environment, and into the layer 2 section, into the you know. Oh, sorry, that's a terrible drawing. Let me just do it again. So this is how you would plumb it in, and then that would allow for communication between the old and the new environment for SD-LAN. Obviously, looking at that, and it looks like that's like an oversimplified version, but that's pretty much what Cisco's guidelines and recommendations. And I had a thought, I had a think about it earlier on, just to make sure, you know, based on my own experience of doing various different migrations with overlays, underlays, things like that, it made sense to me. So it was off Cisco Sales Connect. It was quite old, but I can't see why that probably would have changed. Because it's the same concept. I think like we're at the stage now with SD-Access where it's just feature requests which are getting added rather than you know, architectural changes. So let me look and see. So yeah, that would be from a layer 2 perspective, and then if I use red ink for a layer 3 perspective, that could either go into the distribution or it could go into the core. Probably the core, because you're just using it as a transit, and then it can get either this way or that way, depending on wherever it needs to go. One thing I just want to skip back and talk about, just literally for a minute, that I never mentioned, and it's critical that you know this. We talked about if the VXLAN environment. However, what about if something wants to route out of the fabric? So if let's say the red wants to route out of the fabric, in that case, instead of broadcasting across the VXLAN overlay, it's routed up to these border nodes, which are seen as a gateway, and then that basically sends the traffic onwards. So based on where you're trying to get on the network, whether it's a routed or a switched path, then that's going to determine whether you stay inside the fabric and you use all the Lisp, RLOC, etc., which I explained, or if you just hit the Anycast gateway, which would be .1 over here, and it would also be .1 over here. So you don't have to have different default gateways for different hosts, for example. It would always be the same default gateway, and then if it hits the default gateway, it knows to send it up here and then onward to like onward connectivity, servers and things like that. So that concludes the presentation. 2 minutes over at this point. Still got most people, about 40, 42, 43 actually joined, and we've got 35, 36 left. But one question, what's the approximate overhead added to the IP header? I honestly don't know. It's VXLAN, so if you do VXLAN overhead, I think it's about 20, what is it, 50 bytes. 50 bytes for VXLAN, I think that's it. No more questions come in just now. What I'll do is, if I'll just be sending an email out just to get some feedback and stuff on the teaching style, because if people want to see more of these, I'll do more. But if there's things that I can tweak to make it better or more interesting or whatever, then happy to look at that. So I've got an email list. Reply to it. It'll be like 2 questions. Did you enjoy it? And maybe one other question or something like that. And it'll be anonymous, so you don't even need to put your email address in. All right. So on that note, thanks everybody. As I say, people from all over the world, I really appreciate it, and enjoy the rest of your evening, morning, afternoon, whatever it is, wherever you are.